Right. So what is the JNDI? So I'm getting some noise from you, from you people actually.
Okay.
All right. So Java naming directory interface. JNDI is nothing but Java naming directory interface. So generally, what is that? As an administrator, what we need to do, and what we can able to do in the JNDI concept. So JNDI concept generally Java naming directory interface. It is nothing but it is a standard Java API. It's nothing but application package interface, which was already there. We need to be called and we need to be accessed, right? JD is nothing but Java naming directory interface is an API for accessing the different naming and as well as directory services. In the sense, so naming services and directory services which are going to be accessed by using the JPI over the network, right? So that is possible by using the JNDI concept. So generally, what are the main reason which was introduced in the JNDI? Generally, there are two reasons actually. So the first one, to avoid the naming conflicts, and second one, so to avoid the duplicates. These two reasons actually. See, if you configure using the JNDA, or if you can able to look up the JNDA using the JNDA, generally what will happen, so there was no duplicates actually. It is going to be straight away go to over there and look up that service. It may be either it may be a name based or either it may be a directory based. That is about that JNDI and purpose of the JNDI. Let's we see why JNDI is required in the WebLogic server generally. So in WebLogic server generally, JNDI serves as a repository. In the sense on that repository, and it has going to be lookups all the J2EE objects such as EJB, JDBC, JMS, and including the queues and topics and remote method invocation stubs. All these services over the network to look up, right, to look up those objects in the separate repository called JNDI. So use it may be a name based or directory based, JNDI service. So clear, right? What is the purpose of the JNDI? So JNDI, which is used to find out the objects. What kind of objects it is going to be find out? EJB, JDBC, JMS, and RMI over the network. So by looking up these J2W for looking up these J2W objects, which will use the JNDI in the WebLogic service. So only these cases. All right. So let's we see what is the architecture of the JNDI actually. JNDI architecture. This should be a architecture of the JNDI server. This is the application code which is designed and developed by the developer. And this is JNDI API. These are all these three you can call it as a JNDI. By using this code, you can able to call the JNDI API, and it is going to be look up based on the corresponding drivers. It is going to look up these services, right? So fortunately, you don't want to install any drivers in the WebLogic server. By default, whenever you install the WebLogic server, automatically the JNDI servers will get need to be configured at the time of configuring the JDBC and JMS, and we will able to access over the network whenever it is going to be lookups by the client service or client application. Right. What are the types of JNDI concepts which are available here? There are two types of JNDI concepts which are available. One is naming concept and second one is directory concept. What is naming concept and what is directory concept? See, naming concept generally, so it is the naming service. That means generally what will happen, objects are going to be found based on their names, right? Based on their names, it can able to find the objects. Example, generally what will happen. So whenever you use an electronic mail system, generally what will happen, whenever you want to send any message to any recipient, right, to whom you want to send, generally how to be provide the recipient mail address or recipient name. So then only you can able to send. If that matches, generally then only it is going to send messages to that recipient. Else you will get the delivery notice. So in the sense, runtime it is going to look up those objects based on the names. Similarly like that in WebLogic also. So whenever you use naming service based on that name, it is going to look up those objects and find the objects. That is what naming concept. Example is electronic mail system. So coming to the other one called next, what is that? Directory service generally. See, objects cannot not only can find the objects can by using the naming service, and also it is going to be using the attributes. Based on the attributes also, it is going to be find out the objects. What are those attributes actually? See, if you take the telephone company directory service, what will happen in that? If subscriber maps to that his address, generally you will get phone number and as well as a referee and his address and everything based on one directory. Is nothing but what his subscriber name is nothing but directory. Based on that, it is going to be displaying the remaining attributes also. So you can use by using the remaining attributes also, you can able to search the you can able to find out the you know objects. That is what directory service. So we will use always in the WebLogic server naming service only, not directory service. Right. So what are the important points about the JNDI actually? So generally, Java applications, whenever you use the naming service to locate the objects in the data source, EJVs, JMS, mail sessions, and and so on in the network actually, to find out all those, to find out all the services over the network, generally we use the JNDA. So generally, let's we see that is important. There is no dependency on one JNDA service and other JNDA service. In the sense, there is no dependency on the naming JNDA service and a directory service. Each one you can implement independently. There is no dependency on one and another. Each one you can implement independently. Right. So as an administrator, what we need to do in the JNDA concept generally, we need to be verify whether the JNDA objects are bound into the JNDA tree or not. Otherwise, we can monitor how to view the JNDA tree, whether the objects are bound into the JNDA tree or not, and you can set security on context within the JNDA tree. So these two we can able to do as an administrator. We need to know about the JNDA concept, and as well as these two responsibilities or these two jobs will do your the in the production environment. Let's we see how you can able to view the JNDA tree. For what purpose you can able to view the JNDA tree? By using the JNDA tree, you can able to monitor your deployments, whatever you deployed applications in the WebLogic server. You can monitor by viewing the JNDA tree from the WebLogic server admin console or by using the different method also. So for that, what are the steps actually? Start admin server, log into the admin console and click on lock and delete button and expand the environment node and click on the admin server and click on view JNDA tree and it will open the separate browsable window, and one side you may have the JNDA tree structure, other side you may have the JNDA home. So in that way you can able to monitor like this. See left side you may have the JNDA directory structure, JNDA tree structure, and right side this is called what JNDA home. This is called JNDA home. Let's we see how what are the things you can able to do in WebLogic server, JNDA server as a repository to look up the J2W objects by using these EJB, JDBC, JMS resources like connection factory, queue topic. All those it has going to be looked up by the JNDA service only at runtime. Let's we see how you can able to view and how you can able to set the security. So go to over there. So expand the environment node, click on the servers and click on admin server. Click on view JNDA tree. See, this is what JNDA home. I told you right. It is going to be look up in the EJB objects and as well as JMS objects and as well as transactions and JDBC cluster. EJB is nothing but cluster. Everything you can able to monitor by using this here to look up what are the connections actually default. By using this, whether the objects are going to be bound into the JNDA tree or not, you can look up by using this. So it's an interview question actually. How to view the JNDA tree? So what are the steps actually? This is in this way you can able to view whether the objects are going to be bound into the JNDA tree or not. Next, second responsibility, how you can able to set the security. So click on the security and click on new. There are two things which we have actually. Just provide the name and click on OK. In the sense, you can create the rules and as well as the policies. Depends on the requirement, you can create the role and you can policy and you can provide the security for the JNDA, for the JNDA, only for this JNDA. In this way, you can able to monitor and as well as, set the security. Right? So this is about generally normal JNDA. So we can able to do as an administrator that only. So coming to that advanced concept, generally JNDA which is going to support the clustering support also for GDBC, JMS and as well as WebLogic server cluster actually. So generally what will happen, it is going to be replicates. This one you can get, it supports the clustering service also. Cluster wide services. Generally what will happen whenever the object cannot found into the naming tree, so generally it is going to be removed from the naming tree and rebound that object into the naming tree like this. Server A, server B, if it is not available, it is going to be removed and rebound again. And other important thing was JNDA, which is used for removing the naming conflicts. Generally, naming conflicts generally occurs when the server instance attempt to bind the service with the JNDA and the name already exists. Either it may be clustered, the services are non-clustered. So to avoid the naming conflicts and deploy the cluster objects, into the server. So that is the reason we are using the JNDI. So this is about the JNDI concept and purpose of the JNDI concepts. So the following questions they will ask in the JNDI. The first one, what is the JNDI tree and what is the purpose of the JNDI tree in the WebLogic server, and what are the types of JNDI trees available, JNDI tree services, what is naming service and directory service, then what are the important points about the JNDI tree, then how you can able to view the JNDI tree, otherwise how you can able to monitor the whether the objects are going to be bound into the JNDI tree or not. Then so what is the purpose of the JNDI tree and how you can able to set the security context in the JNDI tree. So these are the questions they will ask in the JNDI tree. Clear, right? Java naming directory interface. Hello.
Mm-hmm. Yes, sir.
Right. This is mainly which is used for to avoid the naming conflicts and duplicate in the sense avoid the I mean duplication part, right?
Okay.
So at the time of configuring the JDBC JMS, we'll use again this whenever we are creating the services, we'll use the JNDA service and we can able to create the JNDA services. Okay. So this is about the JNDA concept. And once we will complete this JNDA concept, very very important concept, we are moving into that clustering concept actually. So what is a cluster and why we are using the cluster actually? So cluster is nothing but what a cluster is nothing but two or more interconnected systems that create a online solution actually. That create a right. It has going to be a cluster is nothing but two or more interconnected systems which is used to coordinate for providing the following features like load balancing, failover, and scalability. Right? Otherwise, cluster is nothing but a group of WebLogic server instances working in coordination. It provides the following features called availability, scalability, and load balancing. So let us just take something like that. See, I'm working say www dot online sd.com. So the moment I hit this URL, it is going to be open that application. Right. So which is able to get actually. In the sense, if the only one server if you have, if that server is going to be crashed or unable to process the request, what you can able to do generally? See, there is no way to access by the client, right?
Yes.
So for that reason, the clusters was introduced actually. High availability, load balancing, and scalability. So what is a cluster? Cluster is nothing but two or more interconnected systems working in a coordination for providing the following features. What are those? Scalability, high availability, and load balancing. Let's see generally, other one called what are the services which we can able to cluster in the WebLogic server? Important interview question. So generally, the following services which we can able to cluster: web applications, EJB and RMI objects, and the JNDA tree. WebLogic server generally it is going to be providing the following clustering services for JDBC and JMS connections also. So these are the services which we can able to cluster for the in the WebLogic server. Interview question: which services can be clustered? JDBC, JMS, web applications, EJB and RMI, and the JNDA tree. So these are the services which we can able to cluster in the WebLogic server. Let's we see why we need the cluster actually. There are two advantages. One is scalability and load balancing. What is the scalability and what is the load balancing generally? Scalability is nothing but what see, whenever the load is increased, which means day by day the clients are going to be increasing to the SBA application. Whenever the
Yes.
load is increased, how you can able to do generally by adding the another servers, by adding the few servers to that, we will able to again share the load and we are providing the high availability. So that is possible by configuring by using the JNDA tree. Whenever the load is increased, you can add the servers. Whenever the load is decreased, you can remove the servers without disturbing the existing services. That is called scalability. So load balancing means if the load is increased from the client, then what we can able to do? So if already all the servers are going to be busy, or few servers are busy, it is going to be checking out and redirecting to the or distributing the incoming request across all the server instances in the cluster, right? Based on its availability. And high availability means if any one of the server in the cluster generally it has going to be fails. If it does not, those servers does not added into the cluster, what will happen at that moment? Immediately client able to get the error. If you are in a cluster, what will happen? The application which checks about that, application checks about for the other another cluster in the cluster node, another server in the cluster node, and if it is available, which is forwarding the request through that another node. It's nothing but another object come into the picture and take over the job and continuing the process. End user does not able to get any error. So that is possible by using the high availability. If any one of the server is going to be fails in middle of processing the request, there is no issue if the servers are in a cluster and which is redirecting to the other node in the cluster and continuing the process. By that end user cannot able to affect. If you are not in a cluster, immediately it is going to be throws the error. These are about the three reasons we are going to be configuring the clusters. So what are the benefits of the clusters? Scalability and high availability. I already told you scalability is nothing but which allows you add whenever load is increased, you can add the servers. Whenever load is decreased, you can remove the servers without disturbing the existing environment. High availability means, generally when the WebLogic server is going to be fails to processing the request. So generally what will happen? Other server come into the picture and take over the job and continuing the processing. By that client cannot able to affected. So that mechanism we can call it as high availability. Let's we see generally what are the key capabilities of the cluster. Another important interview question. What are the key capabilities of the cluster? There are four key capabilities actually. One is application failover, and second one is site failure, and third one server migration, and four load balancing. Let's we see application failover. See, I am working on something here. So in this application, suddenly this application becomes unavailable, which means this application becomes unavailable. What will happen when an object in an application is performing some task and all of a sudden it becomes unavailable, task becomes unavailable. So at that case, generally what will happen? If you are in a cluster, immediately another object come into the picture and take over the job and finish the job, right? Another object will take over and finish the job. That is called application failover. And site failover means generally what will happen? So the production data which are going to be maintained into the different data centers, in the sense one site, another site. So at the same time, it is going to be syncing the information from the production server. And unfortunately, what will happen? So all the server instances and single site. So generally, what will happen? All the applications where do you have is that the data center unable to process the request. Generally, applications in the single site it is going to be fails to processing the request. So immediately what will happen? It can switch to the another separate site and continuing the process. So simultaneously one is active, another one is passive. Whenever the site is going to be fail, which switch to the another one, it becomes like as a active again. Another site it becomes active. Once it is passive, another one. So that is called site to failure. And server migration means generally in the cluster, some of the services are going to be failed. Those failed services which are going to be recreated on the running server instance, which means only failed services or affected services which we can able to recreate on the running server instance, which is called server migration. So what is load balancing generally? Load balancing is nothing but it is going to be distributing the incoming request across all the WebLogic server instances equally. For example, if you have three servers in the cluster, you are getting the 100 requests from the client, 33, 33, 33, which is going to be divided and sends request to the across three server instances in the cluster. If any one of the server is not unable to process the request and which is divided by 2 again, that will do by the load balancing, right? These are about the key capabilities of the cluster. Let's we see another important interview question. What are the types of the clusters which we have in the WebLogic server generally? There are three types of clusters: horizontal cluster, vertical cluster, mixed or hybrid cluster generally. Horizontal cluster, vertical cluster, mixed or hybrid cluster. Let's we see what is the vertical cluster generally. Right. So generally what will happen? So vertical cluster, horizontal cluster. So vertical cluster means generally, multiple Java applications. Otherwise, the servers are going to be reside in the single machine, right? Servers are resides on a single physical machine, which means how many servers you want you can create in the single machine only. Everything you can monitor and you can configure, and how many applications do you have? Everything you can able to configure in the single machine only. That is called vertical cluster. In other words, in vertical scaling, it consists of multiple Java application servers on a single physical machine. How many, see, based on that hardware software configurations, you can configure how many server it is going to be configured. Then that many you can configure in the single machine only. So in the sense, whatever we are doing in the practical, that is called vertical scaling only. So vertical scaling generally, which is depend the server configuration on the following parameters generally. What are those? CPU processing and CPU usage, Java heap memory configurations. Generally, based on the CPU process speed and memory are the main factor to decide how many server instances which are going to be configured in one single physical machine. So that is about the vertical scaling. So based on this only, it is going to be gives the performance. If you have the high or enough memory and as well as enough CPU process, then it will give the bit performance high. So let's we see the architecture. It looks like, see, all the server instances in the single mission only here. Domain, admin server, and manager servers here. This is called architecture of the vertical cluster. Let's we see what is the horizontal cluster generally. Horizontal cluster, the servers are going to be reside into the different machines. In the sense, multiple Java applications which are going to be running the multiple, which involves running multiple Java application servers that are run on the two or more physical machines. In the sense, you can create the servers different machines in the different machines. Generally, horizontal scaling, which we'll use in the production environment. Interview question: which type of clustering architecture did you follow in your production environment? So horizontal scaling. Generally, horizontal scaling is more reliable than the vertical scaling because while 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 domain in the horizontal scaling, if any one of the machine is going to be crash, which we can able to get in the form of in the form of another machine's backup, and we can restore without any trouble. And second point, no need to depend on the hardware and software configurations. Based on the system's configuration, you can configure the server, and again you can distribute the server instances. So in that way, so it is going to be giving the more performance and as well as it is reliable than vertical scaling. This is single point of failure. Once it is failure the machine, there is no way to take the backup here. And here we may have the backup in the form of other machines actually. This is about horizontal cluster scaling, and in the real time or in the production environment, we will use the horizontal cluster scaling only. Let's we see architecture of the horizontal cluster generally. This is architecture of the horizontal cluster. See, machine 1 and machine 2, machine 3, machine 4. Depend on the load, you can add like that, right? There is no limit actually. So that's why application servers which follows the three tier or entire architecture. So this is about that. In this way, you can able to configure or you can able to see the horizontal cluster architecture. So let's we see hybrid or mixed cluster means the combination of both horizontal and vertical scaling. We can call it as hybrid or mixed cluster. Sometimes what will happen, most of the administrators, they are going to be support dev environment as well as production environment. In the dev environment generally, which does not require the horizontal cluster scaling because they are designing and developing the applications there. For that, it does not require more servers actually, right? So to some servers only enough to test, to design, develop, and to test the developed applications. So there is a reason when who are supporting the dev and as well as the production. So they are going to be supporting the mixed or hybrid cluster. So this is about that three types of the clusters. Let's we see what is the architecture of the cluster. This is C. This is complex architecture. In other words, horizontal cluster architecture. See, whenever the client raises a request, this request which is forwarded to here you may have that, her load balancers. So later you will get what is the load balancers, software load balancers, and as well as the hardware load balancers. By using these, the requests are going to be load balancing and distributing the request across all the server instances in the cluster. It is going to be forwarding to the three server instances, server 1, server 2, server 3, based on its availability, and remaining process which we will do again. This is about architecture of the cluster actually, horizontal architecture. And let's we see basic cluster architecture, everything in a single machine only. server 1 and server 2, and these are all called web container, and each web container means application 1 and application 2, which is going to be targeted. So this is about the basic cluster architecture. So let's we see generally, that is about that, so cluster and its introduction. Let's we see the major the advantages to implementing the cluster means two things actually. Anyhow, scalability means you can add or remove the servers depends on the requirement. So coming to the rest of the things actually, load balancing and failover. In other words, high availability. What is the load balancing? Then how you can able to achieve in the WebLogic server instances? Important entry question. Load balancing is nothing but distributing the incoming request across all the multiple server instances or WebLogic server instances. Example, let us you take, so if the domain have the 6 manager servers, generally what will happen, each box it may have the three servers, and the incoming request have to be distributed to the across 6 manager server instances. So that is called load balancing. So generally how you can able to implement the load balancing. So before that we'll able to see what is the proxy server and what are the types of proxy servers which we may have. So generally proxy is nothing but what, redirecting the requests. Proxy servers means which are used to provide the load balancing and failover for the cluster. So let's we see there are two types of proxy servers which are available in the WebLogic server. One is software based proxy server, second one hardware based proxy server. Software based proxy servers, again two types. Software based proxy server may be an internal, and or it may be a third party application. Software based proxy server may be internal means, so if you does not configure any load balancers, so by default whenever you install the WebLogic server, it may have the default load balancing capability, that is called internal load balancers. And third party applications means, so for getting the for managing and administrating the load balancing effectively, which we can able to install and integrating with the third party uh, you know software based load balancers. That is second. And third one, hardware based proxy servers. Hardware based proxy servers, these are physical load balancers generally, which is configured and maintained and administered by the network administrator or dedicated administrator. So this is about the proxy server and its types. Then how many ways you can able to implement here? Three ways actually. The first one, hardware load balancers. As per our discussion, what are the hardware load balancer vendors actually? Cisco, ACE, Radware, F5, and most of the market which is used by the F5 only. So in some projects you will get both hardware and software load balancers, but you cannot able to do anything in case of hardware load balancers. We are just associating with the hardware load balancer administrators or network administrators. So this is as going to be load balancing all the hardware devices like CPU, printers, and all those. And this is first method. And the second method, in this does not require the client plugins, which means these are physical load balancers directly installs. That's it. And second one, so third party web servers, in the sense, software based proxy server in the third party. Example, installing the Apache web server and integrating the WebLogic server by using the proxy plugins. So that is second method, in the sense third party applications load balancers. And third one, HTTP cluster servlet, which is nothing but what, internal load balancers. In the sense, if you does not configure any load balancers by default, which we have the internal load balancer, that is going to be supports. Let's we see hardware load balancers, how it is going to be forward the request. See, load balancing using the hardware load balancers generally. See, this is called where the users can raise the request and which is forwarded to the router. Router, it has going to be checks about the networking connections and whether the request is reached to the destination safely or not, and the destination to destination to source, it has going to be reached to successfully or not. You have to know that point. Then it is forwarded to the load balancer here. So this what it has going to be doing, load balancing all the requests and distributing these incoming requests to the server instances. So these hardware load balancers generally, which are interacting again with the software load balancers. So in this way, it is going to be distributing the request to the server, WebLogic server instances. This is first method. And see, before second method generally, which is nothing but what, load balancing using the third party applications. Example, Apache web server and plugins. So generally these are not physical load balancers, so which we need to be install the web server and integrating with the WebLogic server by using the proxy plugins. What is the proxy plugin generally? plugin is the proxy plugin is nothing but what, it's a dynamic content, delicate dynamic content which route the request to the WebLogic server instances from the client. So how it is going to be routes generally round robin fashion. So what are the so by using the load balancing algorithms in that way it is going to be you know load balance the or distributing the request across the cluster instances. Understood? That is about the proxy plugin. And what type of load balancers which are available in the WebLogic server? There are following types of load balancers which are available: round robin algorithm, random algorithm, random load balancing algorithm, and weight based algorithm. And fourth, round robin affinity algorithm, random affinity algorithm, and six, weight based affinity algorithm. So these are about the types of the load balancers. Default one is round robin. In the sense, until completing the request, it is going to be round robbing the request. This is the default algorithm. So based on that, it is going to be distributing the request to the WebLogic application servers. And second one, generally plugins. Generally, what will happen instead of installing the hardware load balancers? Here, what we need to do? So we need to install the Apache web server, otherwise OHS, otherwise any other web server you can install and integrate with the WebLogic server by using the plugins. Similar way, which is coming from the request from the client and which is going to be route to the request to the software load balancers. Here it will do load balancing and test about the request. If it is a static request, here only it manages and send back to the client, and client will display the output. These are the dynamic requests which are coming from the client. Those are dynamic request means which are going to be redirecting to the application, WebLogic application server instances. There it will do some business logic regarding the request, right? So in that way, it is going to be distributing the request by using the third-party web application or application load balancers. Third-party web application or web server or load balancers, right? That is third method. See here, a web server plus plugin, web server plus plugin. Then it is going to be forwarding based on the type of the request, which forwards to the WebLogic server instances. In the WebLogic server instances, which we already configure the cluster. So that is the reason it is going to be distributing the request in this diagram. So let's we see that is what second method of implementing the clustering. And third method generally load balancing using the HTTP cluster servlet, which is nothing but what inbuilt load balancers, right? Inbuilt load balancers. So what is the inbuilt load balancers? Generally, whenever you install the WebLogic server, automatically it comes with the default load balancing capability, but which is only load balance the web applications only, right? Whenever the clients they delivers the request, based on that it is going to be populate or which is going to be route the requests in a round robin style to the servers in the cluster, but only web applications it is going to be distributing the request, not for the enterprise applications. So this is inbuilt or internal load balancer, right? That is nothing but HTTP cluster servlet instead of hardware or instead of third-party software, which we can use now. Internal load balancers for load balancing the incoming request, but it is having its own disadvantages which can load balancing the web applications only. So that is the reason we always go with the third-party web load balancers only. So this is what HTTP cluster servlet, which we can able to distribute the request to the WebLogic server instances. That is about that ways of implementing the load balancing among three, which is responsible as an administrator. So third-party software-based load balancer configuration and integrating with the WebLogic server. So here some of the questions they are going to be asking here. So the important question. So what are the differences between the proxy plugins and as well as the load balancers, right? In the sense hardware load balancers and software load balancers. What is the difference between the hardware load balancers and software load balancers? Important entry question. Hardware load balancers, generally which does not require the client plugins. Software load balancers which requires the client plugins. And hardware load balancers, these are the physical load balancers. Software load balancers, these are not physical load balancers. Hardware load balancer does not have the proxy layer. So by that what will happen? It is going to be reducing the number of connections. Software load balancers which may have the proxy layer which increases the number of connections. And hardware load balancers, generally example F5, ACE, Radware, and Cisco. Software load balancers, Apache Web Server, Oracle HTTP Server, IBM HTTP Server, iPlanet or Sun1 Web Server. So those are all called example of the software load balancers. And for configuring the hardware load balancers and administrating and maintaining purpose, which requires the additional administrator, whereas software load balancers, which does not require WebLogic server administrator only, which is configured and administrator. In some case, so which we may have the separate administrators also. And coming to the other one, last point, so whenever you're comparing with the performance wise, hardware will give you a bit high than software load balancers. These are about the differences between the software load balancers and hardware load balancers. So this is about, in this way you can able to implement the load balancing. So regarding the practical, what we need to do here, regarding the how to set up the load balancer, how to set up the load balancing in the WebLogic server. For that practical, how to install the Apache Web Server. Second one, how to install, how to integrate, the with the WebLogic server. So these two steps we can able to do in case of setting up the load balancer. So this we have seen actually. We see. We will complete the remaining theory and we'll go with the practical. How you can able to implement the failover, generally high availability in the WebLogic server. So what is the high availability? So high availability is nothing but what, any system which can handle the failovers without knowledge of the end user, which means any one of the server or any one of the application, any one of the server which has going to be fails, automatically it has going to be detects and redirecting the request to the another running node in the cluster and continuing the process. So that is called high availability. So generally example, so in the cluster, any one of the manager server is going to be fails in middle of processing the request. So that time what will happen? End user does not able to get any error because that server should be in a cluster and which is going to be redirecting to the another running server instance in the cluster and continuing the process. That is called high availability mechanism. So generally high availability which is implemented by using the failover mechanism. What is a failover mechanism? Generally, whenever the manager server instance is going to be fails in middle of processing the request, which is failover to the another running server instance in the cluster. That mechanism we can call it as failover mechanism. High availability which is implemented by using the failover mechanism. So let's we see how you can able to implement the what is the failover scenario problem generally. So let's we see here which is the request is coming from the client and which is forwarded to the server one. Actually these servers are standalone servers in the sense which are not in the cluster. There is no communication across each server instances, and this server unable to processing the request due to some technical reasons. What will happen? So end user immediately will get the error because these servers are not added into the cluster. So this is the failure scenario problem generally without cluster. So what we can able to do in this case? So we are going to be adding all three servers into the cluster. What will happen whenever the request is coming from the client? Then that request which is going to be launched on the server for first time, that server we can call it as a primary server, and immediately it is going to be create the session into the alternative server. We can call it as a secondary server, and in this way we are going to be replicating the HTTP session. If this server is crashed, no problem, session is available here which is redirecting. So the failover which is implemented based on the HTTP session replications. So what is the HTTP session replication generally? If the server is failed generally, this time it is the primary, then alternative one it is called it as secondary, right? The session is going to be stored within the JVM, which is nothing but Java Virtual Memory. Within the server, it is going to be stored the HTTP session replication. So that is how you are going to be, providing the failover scenario problem. Let's we see what are the HTTP session state replications which are available in the WebLogic server. Interview question again. There are three types actually. in-memory replication, JDBC replication, and file system replication. Let's we see what is in-memory replication and what is JDBC replication and file system replication. So generally, in-memory replication, the session by default this only. The session state exists only in two objects. The session state is going to be exists only in two servers or two objects. Session objects exist only in two server instances. That is one disadvantage. Second one, the session is going to be stored within the JVM memory only. So generally what will happen whenever the primary server is created, immediately which is going to be created the secondary server, and it may have the backup of primary server. Whenever the primary server which fails, then backup object becomes the primary and alternate one it becomes the secondary. So in this way it is going to be implement the failover. See, this is before failover, this is after failover. Before failover, this one, this is fail, this becomes primary and this becomes the secondary. So this is a method one. This is one of the method to implement the in-memory replication. Nothing but HTTP session replication by using the in-memory replication. So generally what will happen in this session state is going to be, session objects exist only in two servers only. Let's we see other one generally, what is that other one? JDBC replication generally. So in the JDBC replication, what will happen? In the JDBC replication, all the server instances has the ability to access the session state at same time, right? All server instances have access to all the sessions. So because the session state which are not going to be stored in the, where we can create the WebLogic server, which are going to be stored the session state under the database. So all the server instances which is required actually, which requires the connection pool to connect to the database for accessing the HTTP session. So whenever you are unable to provide the connection, then all server instances able to access at the same time HTTP session, which is stored in the database. Then all the subsequent requests which are coming from the client can be handled by the any one of the server instance in the cluster. And generally what will happen, it is going to be providing the greater failover capability, because even the WebLogic server is going to be crash, still the session state is going to be safe and secure in the database. But sometimes what will happen, changing the sessions, it is going to be causing the performance. That's why careful about the JDBC replication. So most of the cases, if application is high application, we go with the JDBC replication only. So let's we see then after that JDBC replication, what we need to do generally, file persistent replication. So session state not only you can able to store in memory and as well as the JDBC replication, which is also stored under the file based persistent. In the sense you can create the directory in which you want to store the file, right? So all we need is you have to be provide the appropriate privileges to that file to store into that, to store the session into that file. That is what file persistent. So for that what we can able to do, that part we can able to do. So in this way you can able to do create the directory, and in that you can able to store the session. So in this way you can able to implement the HTTP session, and you can able to provide the HTTP session replication, which is nothing but failover concept, failover mechanism, which is implemented like that way. And then after that generally what will happen, so EJB is also which are going to be replicates across the cluster instance generally. So it will be like this, not require this all. So very important into your question, what is the replica aware stubs generally? See, whenever you are clustering the EJB applications or enterprise applications, the replica aware stub generally which contains the logic which is required to locate the EJB or RMI classes on the WebLogic server instances. Whenever you deploy it, is going to be uh, calls the RMI and as well as EJB objects. It is going to be locates those objects. In that case, we'll use the JNDI. Right. So this is about the server communication in the sense GD, how you can implement the failover and as well as the load balancing. I'm telling if any one of the server is going to be fails, which is redirected to the another server instance. How it is going to be communicates the server instances generally. How it is going to be communicates on one server to another server. Very important interview question. How it would be happen server communication in the cluster. So cluster communication may happen in the cluster by using the two addressings two addressing. One is unicast and second one is multicast. Let's we discuss first multicast generally. See, multicast generally which follows the one-to-many communication model, right? In the sense, it is going to be broadcasting the messages and sending the messages to the server instances, and it won't wait for the acknowledgement. Hence, it is not a reliable communication, and there is a huge network traffic, and there is a chance of losing the data. And generally, UDP, which uses the multicast, which uses the UDP protocol, user datagram protocol for communicating. And what is the default address range of the multicast? Generally 224.0.0 to 239.225.225.225. This is what default addressing of the multicast addressing. Generally, multicast addressing, which has the drawbacks like the network traffic and it does not wait for the acknowledgement, hence it is not a reliable communication. There is a huge network traffic and chance of losing the network packets. Those are all the drawbacks actually. To rectify the drawbacks of the unique multicast, they were introduced in WebLogic Server 9.2 unicast addressing, right? Unicast addressing was introduced to rectify the drawbacks of the multicast in WebLogic Server 9.2. So generally what it will do, it follows the one-to-one communication model which uses the TCP/IP protocol for communicating. In the sense, it is going to be broadcasting the messages and sending to the cluster, sending to the server instances and waits for the acknowledgement. Hence, it is a reliable communication. There is no chance of the losing the network packets and there is a less network traffic. There is a very less network traffic. So that is the reason from WebLogic Server 9.2 onwards, which we can able to use only unicast. Messaging mode is unicast, but it was there both multicast and unicast. We always choose only unicast. If we select the multicast, the server cannot come into the running mode. That is the reason we always go with the unicast from WebLogic Server 9.2 onwards. So this is about server communication. Generally, in the interview, they will ask what are the differences between the multicast and unicast. Multicast generally, which follows the one-to-many communication model. Unicast generally, which follows the one-to-one communications model. Multicast, which uses the UDP protocol, and the unicast, which uses the TCP/IP protocol. And it is broadcasting the messages continuously and sending the server messages to the server instance. Due to that, there is a huge network traffic, and whereas there is a less network traffic, and there is a chance of losing the network packets, and there is no chance. It is not a reliable communication because it does not wait for the acknowledgement. It is a reliable communication, right? So from WebLogic Server 9.2 onwards, which we can able to use only unicast. This is about the differences between the multicast and the unicast addressing. So then after that, let's we see what are the important points about the clusters actually. There are following important points about the clusters. See, whenever you create the cluster and you want to add servers into the cluster, if the servers are running at the time of adding servers into the cluster, you cannot add. You cannot add servers to the cluster. You can stop and you can add those server instances to the cluster. Hence, whenever the admin server is running, then only you can able to access to the admin console. In the sense, so admin server you cannot able to add to the cluster from the admin console. And even it was recommended generally, to does not add the admin server to the cluster from WebLogic Server 9.2 onwards. This restriction was implemented because admin server purely which is monitored and administrating purpose only. But whereas in WebLogic Server 8.1, so even admin server also you can add into the cluster instances. Even now also you can add, but it is not recommended. So these are about the important points about the cluster. And generally, a cluster can be spread across the multiple boxes, but there can be a more than one cluster you can create in the same domain. And a cluster cannot have the server instances from the two different domains. And generally, how you can able to specify the cluster address? Cluster address you can able to specify by specifying the comma and the list of the member addresses. So these are about the important points about the cluster instance, cluster service. Let's we see how you can able to set up the cluster. We have seen theory, and first we can able to set up the failover, and later we can able to set up the load balancing. Setting up the cluster. There are following methods actually. Configuration wizard at the time of installation. If you know everything at the time of installation also you can able to configure the cluster. And second one, using from the admin console. And third method using from the WLST. Let's we do the practical. Go to here. So go to this path /config.sh. Right. So click on next. Click on next. So provide the domain name and click on next. And select the mode. Click on next. Select the admin and manager server instance. So click on next. How to configure the manager servers? Click on add CMNG1. Like that, how many servers you want, you can configure. And click on next. And click on add. Configure the cluster. How many clusters you want, you can configure. There is no limit. See, messaging mode unicast only. Even though both it was there by default mode unicast only. Click on next. You can add servers to the clusters. So generally there is no limit to add servers into the cluster, but for administrating purpose we will select some servers into the one cluster and some servers into the different cluster. Click on next. Click on next and give a moment for configuration summary here and click on create. It is going to be create the domain and start it with the clustering service and click on done button. This is one method. Second method, start the admin server, log into the admin console and expand the environment node. Click on the expand the environment node. Click on the servers and if you want you can add additional servers here also. HMNG 4 localhost 8040. Click on next and click on finish button, which means I configured additional server instances. Then after that, so click on the cluster and click on new. Provide the cluster name dev cluster and click on OK. So like that, how many clusters you want you can create from by clicking on new. Then after that I need to add servers to the cluster. So click on created cluster, click on servers and click on add. See here it is going to be listing the servers. Select the server from the list. Click on next, finish button and similarly like that how many servers you want you can add servers into the cluster. In the sense we have configured two methods. Okay, so third method, for configuring the third method, because using the WLSD which requires the some basic things to do this service or to do the configuration, cluster configuration in the WLSD, that part we will able to see in the WLSD. In the sense we have set up the clustering environment for failure and still we have not set up the load balancing. So in this way we have completed to set up the clusters. two methods we have completed. Every service which we can able to create again by using the WLST. It's a command line configuration about the WebLogic server services. So every configuration we will able to see again in the WLST whenever we will get the WLST concept. Clear, right? Hello.
Yes, sir.
See, to set up the load balancing. To set up the load balancing, actually it will take much time. Actually, it will take about 40-45 minutes. So we'll see in next classes. Actually, we'll see this next classes, and we can test, and we'll able to see advanced clustering, and so we will complete this clustering concept. All right. Hello.
Yes, sir. Hello?
Understand, right?
Yes, sir.
And what about women? We will meet on Monday, right?
Yes, sir. Monday.
Monday at same time. From Monday onwards, I can able to take more time. Okay.
Okay.
And all right. And if you will get any chance, you can we will able to start some bit early also. Okay.
Okay.
All right.
Okay. Okay.
Right. So we will meet on Monday, right? Monday 6 o'clock. I guess
Yes, sir.
6:30 or 6 o'clock. Okay.
6 or 6. Okay. Just
Right.
mail us. Sure.
Yes, yes. I will mail you before a day only. Okay. Tomorrow
Okay,
end of
sir.
the day I will mail you.
Okay.
Thank you. We'll meet in next session. Bye.
Yes.